Okay, today we are going to do notes on solving rational equations. This is the first day, and today is super easy because this is something that you've done in Algebra 1 and Geometry. We are going to be dealing with proportions, which means that we can just use cross products. So we can use cross products to solve a rational equation when each side of the equation is a single rational expression. Essentially, that means it has to be a proportion. So you have one fraction equal to another. That's a proportion. That's when it's legal to use cross products. Now, what's different about these is that we're going to be having times when we have x values in our denominator. And so let's say, for example, that we solved example 1a and we got x equals 2. Do you see a problem with that? Well, notice that if I put 2 into x, 2 minus 2 is 0. 5 over 0 is not something we can deal with. So we have to make sure that our solution fits in our domain. Remember back in chapter 6, we said that when we see variables in the denominator, we cannot have it equal, the denominator equal to 0. So we check to make sure that our solution does not create a denominator of 0. Okay, so that is what we mean by check for extraneous solutions. If we get a solution and it makes the denominator 0, that's extraneous, so we get rid of it. So my suggestion, because I would always forget about that, so my suggestion is to find the domain first so that you think about it. So my suggestion is to determine the domain before solving and then make sure your solution fits in the domain. And a lot of us struggled with domain in chapter 6 anyway, so I really think that would be a good plan. So let's look at example 1a. First, let's check out our denominators. Notice that our denominators deal with x minus 2, and so we know that x minus 2 cannot be 0, and we also have 2x minus 2 cannot be 0. And so if we solve those, we see that x cannot be 2, and if we add 2, divide by 1, x cannot be 1. So that's essentially our domain. So as long as we don't get solutions that are 2 and 1, we're good. So let's cross multiply. Let's multiply numerator by the denominator that's across, numerator by the denominator that's across. The order that you put it on, like the side you put it on, doesn't matter, but one pair of cross products goes on the left, and that's equal to the other pair of cross products on the right. So then we can distribute 12x minus 24 and 10x minus 10. Then we can subtract 10x add 24, and we get that x equals 7. And let's check if 7 was legal. Well, 7 was in the domain. The only thing we couldn't have was 2 or 1. So that's our solution, x equals 7. Let's try the same thing in letter B. As far as our domain goes, we have our denominators of 7 and 15. So if we try to set those equal to 0 or not equal to 0, notice it's not a problem. So that means that our domain here would be all real numbers. So that means anything we get in letter B is good. So let's multiply. I'll multiply x times 15, set that equal to 7 times the quantity 2x plus 2, and then we can go to town. 15x equals 14x plus 14 when I distribute. I subtract 14x. I get that x is 14. Again, our domain was all real numbers, so x equals 14 is great. See, this is a great lesson. All right, letter C. Let's multiply, let's do denominators. So I look here, and here's a denominator involving x. So I know that 2x minus 3 cannot equal 0. So I know x cannot be 3 halves. And then here this 5 is fine. So the only bad number would be 3 over 2. All right. So now let's cross multiply. Let's take x times 2x minus 3. Set that equal to 5 times x plus 2. Again, you could have them on different sides. That's fine. I distribute 2x squared minus 3x, and then 5 times x. So 5x, 5 times 2 is 10. And notice that in letter C, I get a quadratic. Well, I know that in a quadratic, instead of isolating x, I'm going to get one side equal to 0. So I need to move these guys over so that I can get one side equal to 0. So I end up with 2x squared minus 8x minus 10 equals 0. When we have a quadratic, a very efficient way of finding solutions is to factor. I notice that there's a common factor of 2, so I'm going to take out the common factor of 2. So I have 2 times the quantity x squared minus 4x minus 5. And then I can factor that completely. Notice what a good student I am. I factor and I keep the equal 0 on the right. And to make x squared, I use x and x. To make negative 5, I can use 5 and 1. And to make the negative 4, the 5 should be negative, 1 should be positive. So that my factors are 2 times the quantity x minus 5 times the quantity x plus 1. Now, I would set each factor equal to 0. The 2 doesn't have an x, so we don't worry about it. So this gives us a potential solution of x equals 5. And this gives us a potential solution of x equals negative 1. We double check. Notice the only illegal value was 1.5. So that means that this has 2 solutions, 5 or negative 1. You don't have to write the or, but I feel like I should since this is videoing. Okay, so now letter D. Let's look to see if we have any issues in our denominator. So notice that one of our denominators is p minus 1. So I know that p minus 1 cannot be 0. So that means that p can't be 1. But I also say that p squared minus 3p plus 2 cannot equal 0. So that means to find the restrictions for something like this, I would just factor p minus 2, p minus 1 does not equal 0. So here p cannot be 2, and once again p cannot be 1. So our restrictions here tell us that p cannot be 1 or 2. As long as we don't get 1 or 2, our solutions are good. So let's actually proceed with cross multiplying. I'll take 1 times p squared minus 3p plus 2, so that's just p squared minus 3p plus 2. And now set that equal to negative 6 times the quantity p minus 1. So I'll leave this p squared minus 3p plus 2 alone. Now I'll multiply negative 6 times p and negative 6 times negative 1 to get negative 6p plus 6. And I notice that when I distributed everything, I have a quadratic. So the quadratic, we want one side equal to 0. So I'll have to add 6p and subtract 6. So I have p squared plus 3p minus 4 equals 0. And to factor, there's no GCF, so I can make a double bubble, and p make p squared. And I think it's pretty obvious that we would use p plus 4 and p minus 1 as my factors. Again, setting each of those equal to 0, I can see that p equals negative 4, p equals 1 are potentials. Then we just double check to make sure that negative 4 and 1 are legal. Uh-oh, 1 was one of the values that was not in our domain. Remember, p can't be 1 or 2 because 1 or 2 would make denominator 0. So even though we get P equals 1 as a solution, this is what we're talking about as far as an extraneous solution that we want to get rid of. So the only valid solution is P equals -4. That's the only solution that would end up working. And so again, our answer is just P equals -4. Let's look at letter E. So I'll multiply these together. So I have, let's do the denominators. So if I take my denominators, x minus 2 can't be 0, so x can't be 2. And 2x minus 5 can't be 0, so x cannot be 5/2. So here, these are numbers that I'd want to be aware of. I want to make sure I don't get 2 or 5/2. So let's cross multiply. I have 3x minus 6 times x minus 2. And I'm going to set that equal to x times 2x minus 5. So notice there's quite a bit of distributing going on here, isn't there? Make sure that you distribute everything, that I take 3x times x, 3x times -2, -6 times x, and -6 times -2. And then over here, I have x times 2x and x times -5. So just make sure that everything is distributed. So notice here we end up with 3x squared minus 12x plus 12 equals 2x squared minus 5. Once again, we have a quadratic, so we want to get one side equal to 0. So they both have quadratic terms, but this quadratic term is bigger, so I'll move these guys over. Minus 2x squared. All right, so I end up with x squared minus 7x plus 12 equals 0. And there's not a greatest common factor, so I can try to factor by double bubble. And to make x squared, I have x and x. To make 12, I have several options, but the best way to make -7 is -4 and -3. And so I end up then with x equals 4 or x equals 3 as potential solutions. So we go back and we double check. Notice my domain restrictions would be 2 and 5/2. Notice 4 and 3 are good. So I have both of those as potential solutions. X equals 4 or x equals 3. All right? That's the gist of it. There are 3 U-try problems that are on the back that you can definitely try. The worked out solutions are on the website. If you've been working ahead or if you want to try these before trying the homework, your answer for U-try A should be x equals 10. Letter B is x equals 8 or x equals 1. And the answer for C ends up being x equals 3. Again, the worked out solutions are on the My Classes website for you, okay? The only other thing I want to do before you can start your homework is a problem like example 2. So example 2 says it costs a manufacturing company $50 to make one tennis racket. If the initial investment in the product line was $25,000, how many tennis rackets must be produced before the average cost falls to $75? Now some people start arguing with me and they're like, Miss Lang, this says falls to $75 and you're starting at $50. That's an increase. But what this is saying is that it's $50 to make one tennis racket. This investment, this $25,000, even before you made a tennis racket, you spent $25,000. So like the first tennis racket was $25,050 because it was $25,000 for the investment and then the $50. So that's kind of expensive for one tennis racket, right? So what you might do is say, all right, well, I want the cost of everything to be $75 per tennis racket. So I wanted to explain that to you. So what you do is you think about taking your total cost and dividing it by the number of rackets, and that is going to give you your average cost. So let's think about the total cost for these tennis rackets. We started by paying $25,000 for the investment. Now, in addition to that, we pay $50 for every tennis racket. So let's have X represent the number of tennis rackets. And so now we can say 25,000 plus 50X is our total cost. Again, the number of rackets then would be X, because we're spending $50 for each of these rackets. And now we want to know when the average cost is now $75. Notice that now that we've set this up, this is a proportion, because really this is like 75 over 1. So we can cross multiply. We can take X times 75, 75X equals 25,000 plus 50X times 1, so 25,000 plus 50X, and then we can solve. We can subtract 50X to make 25X equals 25,000, divide by 25, and we get that X is 1,000 rackets. So that means that we want to make sure that our company produces 1,000 rackets, and now instead of costing $25,050 to make one racket, now it costs $75 for each of those 1,000 rackets. And I think that should give us a good start on the assignment. And so you guys can start working on that. It's on the assignment sheet. And that should do it. All right, you guys have a nice day. Thank you.